All right, so here is, and I'm gonna work it like from scratch, like instead of just having it already done and kind of saying, here's how you do it, you know. I'm gonna work it like from scratch, like we're taking the test together. The easiest questions are some that people are still missing, and they're the first three. They're the fill in the blank questions. So, name, right? That answer will vary, but I do check the spelling. Date. Not yet, but still trying. Okay. Prom. Not yet, still trying. Staying hopeful. On several websites. May happen someday. Okay, good. So, or you know, whatever. And then period, that would be second, right? Or two. Okay? So that was easy. So everyone should have that one. So make sure you fill those in. All right. Hey, let's read the instructions for one. Part 1, multiple choice. Put the capital letter. Ooh, I've been using lowercase. That's good to know. I'm glad he has been counting off because he's so generous. He's so nice. Of the correct answer. Ooh, that's what some people don't read. Some people are putting incorrect answers next to the numbers, okay? The instructions clearly say to put the correct answer next to the number. All right, so here we go. Number 1, what is the range of this function? Well, I would say from easy to hard, somewhere in there. Okay, but that's not an answer choice. So do we need to put it in the standard transformation form to answer this question? No, we don't. So what I would do, and again, you don't have to do this. Maybe you've practiced enough that you could do it straight up as cosecant. I'm going to pretend for a second that it's sine, because we had a lot more practice with sine. Remember, sine is bounded between high and low. So the domain for sine, if this were a sine function, remember, is the sinusoidal axis d minus the amplitude for the low point, and the sinusoidal axis d plus the amplitude for the high point. Well, let's see. The 5 would go at the back. That is your d value. And the a value is 8. So let's go ahead and write that out then. That would be 5 minus 8 for a low and 5 plus 8 for a high. So that ends up being -3 and 13. Now that is an answer. That's answer choice B. But that is for sine. Now we can go ahead and say, all right, so for the cosecant, it's everything flipped outside of that. So that would be from -infinity with the parenthesis up to -3 inclusive, union 13 to infinity. And of course, that's not specifically an answer choice, but you can write it as y is less than or equal to -3 or y is greater than or equal to 13. And that should be an answer choice. That is answer choice. Come on, please be there. Please be there. I always feel good when I get an answer, and then I see it as an answer choice, right? Because that means that I'm doing it right. Or I'm making a very common mistake, and I'm validating my mistake, but I don't know it. Okay, either one feels good. All right, so any comments or questions or jokes about this one? Nothing? Like, what did the cosecant function say when we walked into the bar? No one. I don't know. What did it say? I don't know. Ouch, I should have seen that coming. I don't know. Why'd y'all bring that up if you didn't know the punchline? Okay. So we're going to number 1. Everyone knows how to do number 1. If I gave it to you again, everyone would get it right. All right, because that's the goal, right? All right, letter 2. What is the period of the following function? Period. Okay, that's the length of one cycle. It's a secant function. So I know that secant period is always 2 pi over the absolute value of b, right? Secant, cosecant, sine, cosine, they're all 2 pi over the absolute value of b. Tangent, cotangent, pi over b. Do I need to put it in the standard transformation form to identify b? Nope. B is always the coefficient of x. Always the coefficient of x. So it's already positive. Whew, that saves me from having to make it positive. That's a lot of work. I have now more energy for other things. So here we go. 2 pi divided by the quantity 3 pi sevenths. Now some people look at that and they try to do it in their head. They're like, okay, that's 6/7, or I don't know, is it 14/3 or is it 3/14? Just take that extra step, right? Stay, change, flip. So 2 pi stays. You change division and multiplication, and you flip 3 pi sevenths to 7 3 pi, and then you can put that over 1, and then Pi's divide out, multiply straight across, and you get 14 thirds. 14 thirds. Not 14 thirds, that's gross. 14 thirds, 14 thirds. And you're like, please be there, please be there, please be there. 3/7, no. 5/2, no. Hey, there it is. 14 thirds. Sweet. Sweet, sweet, sweet. C. If you had used pi over b, you would have ended up with 7 thirds, which is answer choice A. So that's like the bait answer, right? Okay. Any comments, questions, or jokes about number 2? Period. If that were cosecant instead of secant, what would be the difference for this question, for the period? Anything? No, it'd be the same. Good. It would be the same. It would be exactly the same. What if instead of cosecant it were sine? Would it be the same? Yes. What if it were cosine? Would it be the same? Yes, it would. So it didn't matter what the function was. In this case, for the period alone. For the other stuff, of course, it would. All right, then the fun one. You knew there were 4 of these on the test. Find the domain of secant. Okay, so it's not illegal to sketch the entire graph, although that takes time. But here's something that could help you if you forget, oh my gosh, does it start at 0, or is it the first critical value that's a fourth of period, or is it a half period? I don't even know. Well, remember secant comes from cosine. Yep. So cosine, when we flip it, that's phi, and it's the axis point that becomes the vertical asymptote. So it is the first critical value, which for cosine and secant we count by what cycles, quarter or halves? High, axis low, axis high. We count by quarter cycles. So I know I need to find the first vertical asymptote, which is at the first critical value, which is at a fourth of the period. So that's all you really need in terms of the graph. So let's go ahead and list our answer. It's the domain of f, set of all x such that x is not equal to. The first vertical asymptote is at a fourth of the period. I don't know what the period is. Let's find it. It's a secant, so just like we said, it's 2 pi over the absolute value of b. The b value is the coefficient of x. It's already positive, so here we go, without a calculator. 2 pi divided by 2 pi? 1. Right? That is a really nice period, okay? Not that I like first period better than y'all, but, you know, second period's pretty good too. But that's a really nice period. What is now a fourth of that? What's a fourth of 1? A fourth. Very good. So 1/4. There's my starting value. That's the old VA, right? Or the previous VA. I don't know how old it actually is. And now we got to move it. We got to move it left or right. Can we tell from this? Is it pi 8? Nah. I got to do a little work. I got to put it in the standard transformation form. So here we go. 3 secant of. I am going to do it in 2 steps. I'm going to put the x term first and then the constant second, because I don't want to do 2 things at once. If I try to chew bubble gum and walk at the same time, I'm going to swallow my bubble gum and I'm going to trip, okay? And that's not good. So 3 secant of, I'll factor out the 2 pi now, and I get x plus, and I have no idea what I get. I really don't know. So let me go off to the side. I'm dividing out a 2 pi from a pi 8. So pi 8 is divided by 2 pi. Stay, change, flip. So that's times 1 over 2 pi. Hey, multiply straight across, and you get 1/16. So that's 1/16. Now, before I even use it, because there's so much at stake, I'm going to quickly mentally distribute. 2 pi times x, that's 2 pi x. 2 pi times a 16th, that's 2/16, which is an 8, and a pi is in the numerator, so that's pi 8. Now I know it's correct. And notice it's close, close. On the back, some people did not have that second parenthesis to close it. And if you only did it once, I didn't take off. But if you did it on both 10 and 11, I took a point off. So details, right? For every parenthesis you open, you have to make sure you close it, because it's a very different problem technically without that last one closed. Okay, so now I know what the shift is. We're moving the graph what? Oops. Left or right a 16th? Oops. Keep erasing it. Are we moving it left or right a 16th? Left. So in order to move 1/4 to the left, I must subtract the 16th. Okay? So again, as we said in class, it's the opposite sign. If it's a plus there, it's a minus there. So if you look at those together, that is your new vertical asymptote. And now it's just plus multiples of how often they occur. And for secant, if you remember, it's high axis, low axis, high. We have 2 vertical asymptotes per cycle, so it's plus half periods, not quarter periods or full periods. So what was the period again? 1. What's half of 1? 1/2. So it's 1/2 n. And, of course, where n is an integer, so I'll squeeze that in down there. On the back, if you didn't say where n is an integer, I thought about taking off, but I didn't. We've been using that consistently, so as long as you used n and not like z, I gave you the benefit of the doubt that you were talking about integers and not like imaginary numbers. All right, so that's not an answer choice. So now all we have to do is just a little bit of fraction work. A fourth minus a 16th, get a common denominator. That's going to be 4/16 minus 1/16, and you get 3/16. So x can't be 3/16 plus 1/2 n. 3/16 plus 1/2 n. 3/16 plus 1/2 n. There it is, letter D. There you go, letter D. Letter D. All right, that was kind of fun, kind of invigorating too. Ugh. Makes you want to do more math. Comments or questions, or we'll keep it going, jokes about this one? Everyone knows how to do this. Okay, a little sketch like this could be helpful. Could be helpful just for you to see, is it 0 to start with, or is it the first critical value? And you can also see, I'm counting by quarter cycles because it's cosine. So it's a fourth of the period for the first value. That's all you really need to do. All right, number 4. For what angle between 0 and 2 pi, so that's within 1 rotation on the unit circle, does tangent equal negative cotangent? For what angle does tangent equal negative cotangent? Man, how do you even begin to do a problem like this? Anyone get it right and want to share your method? Eeny, meeny, miny, mo, process of elimination. Yeah, what'd you get, Christopher?
I wrote down all the ordered pair of all the angles there.
Of the angles listed. Oh, okay, cool. And then you tried them out?
Yeah.
Yeah, perfect. That is a fantastic method for a multiple choice test. Try out your answer choices. They're numeric answers, so you could try them out. If you plug pi fourths in, do you get a true statement? Well, let us see. What is tangent of pi fourths? 1. What is cotangent of pi fourths? 1. 1 times negative 1 is negative 1. And now you just see if that's a correct statement. Does 1 equal negative 1? No, it doesn't. So it can't be pi fourths. If you do that with 3 pi fourths, you're going to get 1 equals negative 1, which is also not true. If you try 5 pi fourths, you're going to get 1 equals negative 1, which is not true. If you try 7 pi fourths, you're going to get 1 equals negative 1, which is not true. Now, you're only left with answer choice E, which, here's the problem. Just because these 4 answers don't work doesn't mean that there's not something else out there that might work, but it's not listed. So how would you know to answer choice E? Because it says no such angle exists. Well, you know there has to be a right answer, right? There has to be a right answer. And if it's not A, B, C, or D by process of elimination, it has to be E. Okay? So actually there is no such angle where tangent is equal to cotangent. And so that's a nice way to do the problem. Did anybody think about it a little bit differently? Sine can equal cosine, right? Because that's just the x-coordinate and the y-coordinate being the same on the unit circle. That's at pi fourths and 5 pi fourths. But how are tangent and cotangent related besides being cofunctions from each other? They are what of each other? They're reciprocals of each other. That is another way to do it. I'm asking you, when are 2 reciprocals opposites of each other? I don't know. Like, let's try it out. Like a random number like 3. What's the reciprocal of 3? A third. It's not negative a third, right? To get a reciprocal, you only flip it. You don't change the sign. So when will a reciprocal be the opposite of its reciprocal? Never. Okay? Never. So that's another way to do it. If you were to graph tangent and cotangent, it would look something like this. Here's the graph of tangent, and then cotangent. They can't intersect if there's no solution. Cotangent just comes in there like that. Okay? It just kind of nicely kind of gets right there in the middle where tangent isn't. It's kind of like they're spooning but not touching forever from left to right. Like, you know, you can spoon but don't touch. Spoon but don't touch, right? Forever and ever and ever. Or you could say that they just run perfectly parallel to each other through eternity. They never intersect, right? Oh my gosh, forbidden love. They could see each other, but they can never touch each other. Forever and ever and ever. Oh my goodness. Okay. It's not unrequited love. It's just love that can never happen. Okay? So that's it. Now, you didn't have your calculator, so if you did have your calculator, you could have graphed 1 and y1, 1 and y2, and you would have seen this love story unfold on your graph screen. Okay, sweet. Any other comments or questions about number 4? Did someone else do it a different way? Because those are the two ways I would recommend. Okay. Letter 5. If tangent of 2 pi is A, and secant of A is B, and cotangent of C is B, which of the following could be C? Did he just say BC? Oh, man. I'm so confused just reading this. It's not that bad, though. Because look what I start you off with. Tangent of 2 pi. You can evaluate that, right? 2 pi is coterminal with 0. The ordered pair there is 1, 0. Yes? What is tangent of 2 pi? It's y over x. It's 0 over 1, which is 0. So A must be 0. Okay? So secant of A, that's just secant of 0. Well, that's the same ordered pair. Secant of 0 is the reciprocal of cosine of 0. Cosine of 0 is 1. What's the reciprocal of 1? 1, because 1 is really 1 over 1. And when you flip 1 over 1, you get 1 over 1, which is still 1. So B must be 1. Okay. So now cotangent of C equals B, where B equals 1. So now we're saying, okay, cotangent of what angle listed gives us 1. Well, we know from the unit circle that tangent and cotangent are going to be 1 or negative 1 at all of your pi fourths reference angles. Yeah, 3 pi fourths, 5 pi fourths, and 7 pi fourths, because that's where they're square root of 2 halves, square root of 2 halves, plus or minus. We don't want them to be negative 1. We want them to be positive 1. So when is cotangent and tangent both equal to positive 1? When they're not only the same magnitude, square root of 2 halves, but exactly the same sign, which is in quadrant 1 when they're both positive, and quadrant 3 when they're both negative. So the two angles within one rotation are pi fourths and 5 pi fourths. But now we look at the answer choices. Are either one of those listed? Yeah, 5 pi fourths is listed. Okay. I thought about even adding a full rotation to it, coterminal. If I would have added 8 pi fourths, I could have gotten a coterminal answer. But I said, nah, I'll keep it within one rotation. Okay, so that's how you do that one. You just kind of work your way through. Comments, questions, or jokes about number 5? I better write the answer here. I haven't been doing what the instructions said, right? Okay, now I'm caught up. All right, so that completes the first page. Anything to say about the first page? Tomorrow, if you didn't make a 70, you're going to have to reproduce all this work, okay? So we're going for understanding, not just memorizing particular cases. Ideas, processes, concepts, etc. Okay, letter 6. Letter 6. I thought this, he's calling numbers letters. Yeah, I am. Okay. For which of the following functions does f of x equal negative f of x? I thought this would be the easiest question on the test. Okay? F of negative x equals negative f of x, that is the algebraic test for what type of function? Odd, right? You plug in a negative input and it yields a negative output. For the sine and cosine, or the ones we've been, the trig functions, I'll say in general, that means you could take the negative b value out front. Okay? So remember odd, we use the letter O for odd. Okay, orange and symmetric, same thing. 4 of them were odd, right? And 2 of them were even. So it's almost easier to remember which ones are odd by remembering which ones were even, and then it's just the other 4. So which 2 were even with y-axis symmetry? Secant and cosine, cosine and secant, right? Those were the only 2. So sine, cosecant, tangent, cotangent, those are the odd functions. So if any of those show up on Roman numeral 1, 2, or 3, those are odd. Okay, so secant, nope, that's an even function. Cosecant, yeah, that's an odd function. Cotangent, also an odd function. So now if you sound it out, we get ew. The answer then is going to be Roman numeral 2 and Roman numeral 3, which is kind of funny. We're looking for an odd function O, and the answer choice that's correct is E for even. Oh my gosh, we're reading way too much into this. Okay? So I thought that would be the easiest question on the test. I thought that until I started grading some of the tests for 4th period, and everyone was getting number 7 wrong. And I was like, why? Because I worked the key and I didn't find any errors until someone pointed out to me on their test, and I was like, 7 was the easiest question on the test. Okay, why? The function y equals secant of x has the same domain as which of the following functions? Secant of x, hate that, right? That moment when you try to highlight and you scratch it out. Secant of x has the exact same domain as secant of x. Yes, indeed it does. We call that the reflexive property in mathematics, right? You look in the mirror and there you are. Secant has the exact same domain as itself. So a lot of people were putting D, and I was like, wrong, wrong, wrong. Because when I worked the key, Mrs. Lincoln kind of helped me develop the test, and so she came up with these answer choices, and then I kind of proofed it. And when I worked it, I knew what the intent of the question was, and that answer was there, and I didn't even bother checking the other answer choices because I knew she'd have trig functions and not like, dates of historic significance, right? They would be trig functions. So I never caught it. So this should have been cosine. Okay, and for future classes, it will be cosine. Here's how I intended you to do it, right? If you think of the graph of secant, which, of course, secant has vertical asymptotes at odd pi halves, you could think of the other graph that has vertical asymptotes at odd pi halves, or the way I showed you to do in class, which is easier, is just think of the definition in terms of x, y, and r. Secant of theta, not x, is r over x, right? So it is going to be undefined when its denominator x is 0. There is only one other trig function that has an x in the denominator, okay? It can't be r over x because that's secant. It can't be x over x because that's not a trig function. The only other variable available is y. And y over x is the definition of tangent. So tangent and secant have the exact same domain. So I was looking for the answer C, and a lot of people were putting D, and I was counting it wrong. So I did it for about 5 or 6 tests, and then I had to go back first period and count them right. So there you go. 7 ended up being the easiest question on the test, or was it? I didn't give you all a heads up about it because the correct answer was there. You actually had 2 correct answers. But some people might have said, oh my gosh, secant is there and secant is there. I think that's the right answer, but could it be that easy? And now you start second guessing yourself. There's a trick. There's something to this question that I'm not getting. It can't be secant, right? So maybe, I don't know. Maybe it was a harder question because you overthought it. So that was a serendipitous, fortuitous, hopefully, occurrence for y'all. Now, some people put both answers. Philip, did you too as well? McGeehee, you put both? All right. So here's what I would warn you against putting 2 different answers. You don't get bonus points for putting 2 answers on a multiple choice or a free response, okay? You can only lose points if both of your answers are not correct, all right? So don't do that. Pick one answer and go with it. Because if one answer was correct and the other one that you just volunteered happened to be incorrect, you're now losing the points that you already earned. So I know it's kind of nice to point it out, but just be careful, like on a standardized test, okay? They have to both be right, or even on my test, they have to both be right. Okay, any questions about number 7 or jokes about number 7, like stupid math teachers can't even make a test? That's not funny. All right, letter 8. If cosecant of theta is negative square root of 2, which of the following angles could theta be? Ooh, look at that, another multiple choice question. I like it. So whenever you see cosecant or secant, and you have the ratio, it's a little bit easier to work with their reciprocals. We're more comfortable with sine and cosine, right? So if we have the cosecant ratio to be negative square root of 2 over 1, the reciprocal of cosecant, which is sine, must be the reciprocal ratio, negative 1 over the square root of 2, which when you rationalize that is negative square root of 2 over 2. And now you're like, hello, old friend, right? So on the unit circle then, first of all, sine is negative below the x-axis in quadrant 3 and 4. The y value is going to be square root of 2 over 2, so that's going to be here and here. And of course, what's the reference angle where both x and y are square root of 2 over 2? Pi 6 pi thirds or pi fourths? Pi fourths. So it's got to be the pi fourths angle in quadrant 3, which is 5 pi fourths, right? The numerator is 1 bigger than the denominator. And all the way around to 7 pi fourths, where the numerator is 1 less than twice the denominator. Both of those are the answer within one rotation. And of course, the answer choices that are listed are all within one positive rotation. So it's going to be 5 pi fourths and 7 pi fourths, which again is 2 and 3 only, but now it's answer choice D instead of E. So there you go, D. If that had said secant equals negative square root of 2, then you would have put it in terms of cosine, all right? C.R. Tolkien. Okay, sweet. All right. Letter 9, the other fun one on the front. Find the domain. This is the one we practiced for quite a while. Cotangent, all right? So just quickly in my head, cotangent, and that's the one that starts with the vertical asymptote. It's decreasing. All right, so that tells me something, right? That my first vertical asymptote before I shift it is at 0. I'm starting at 0. Just a little quick sketch of cotangent. I know I'm going to have to shift it, so I have to put it in the standard transformation form. So f of x equals negative 2/5 cotangent. The x term is already written first. Okay, that's good. So pi thirds x, and then let's see, plus or minus. Gosh, I don't know. I don't know how to do this in my head. So I'll always go off to the side, and I'll say, okay, 2/3, and I'm dividing out a pi thirds. And now I will stay change flip, and ooh, look at that. And I get 2 over pi. Now, what is the sign? You could put the sign in there with it, but you're factoring out a positive number from a negative, so the sign should not change. And I think that's right. I hope that's right, but I'm going to check, right? Pi thirds times x is pi thirds x. That's good. Pi thirds times negative 2 pi. Your pi's are going to divide out, and you're left with negative 2 over 3, which is negative 2/3. Yes, yes, go me. All right, get out of my way, people. Here I go. So now the domain is the set of all x's such that x is not equal to. Remember our little sketch up here, cotangent, starts at 0. So it's 0. And then I shifted it what? Left or right? 2 pi. I shifted it to the right, so I have to add 2 pi to it. So again, as we said, it's opposite sign. So this was my old VA, and when I add it to 2 pi, I get the new VA. And now it's just multiples how often they occur. Well, again, every time you have a vertical asymptote, you have another full cycle. So they occur every multiple of the period, which I haven't found the period yet. From the answer choices, it looks like it's either 6 or 3. I like 6 better, right? Is that how we do it? Nope. Okay, so let's go ahead and find the period. The period for tangent and cotangent is what over b? Pi or 2 pi? Pi, good. So it's pi over b, and b, of course, is pi thirds. So this is where you want to be careful, because this is the one that is easy to mess up, right? You say, hey, look, the pi's divide out, it's a third. It's easy to do that, but that's not quite right. So take that extra step, okay, and do the dog trick, right? Stay, change, flip. Good boy. So pi over 1 times 3 over pi. And what happens to the pi's? And we're left with 3 over 1, which is 3. Okay, sweet. So now it's multiples of 3. So 3n, where n is an integer. Now, of course, 0 plus 2 over pi is 2 over pi. So it should be 2 over pi plus 3n. 2 over pi plus 3n. 2 over pi plus 3n. That's answer choice A, as Henry Winkler used to say in his portrayal as Arthur Fonzarelli, or the Fonz, on the wonderful sitcom Happy Days. Check it out if you never watched it. Yeah. Okay, any other comments or questions or requests? We finished the multiple choice. We're feeling good, right? We're energized by the math. It invigorates us. We hope it can keep going. We know it's going to keep going. We're happy that it's going to keep going. We got the free response now. Celebrate with a sip of a tasty beverage. Okay. Next one. Short answer, right? Keep your answers curt. Brief. Using correct notation. That's always the same. Look at this. Give simplified exact answers. What does simplified mean? If it's 2/4, call it 1/2. Okay. Man, I wish I would read the instructions more often. For each of the following. Okay. Number 10, f of x is that. Part A, put f of x in the standard transformation form. And I'm not going to shout it, but you can imagine me shouting it unless you want me to. Eliminate any negative b values by using the symmetry of the function, triple exclamation point. Okay, kind of important. So here we go. What's the first step in putting a function into standard transformation form? F of x equals, that's right. If you left off the f of x or the g of x on both of them, that's when I took a check off. If you left it off one of them, I growled and begrudgingly did not count off, okay? So details as we get closer and closer to the end of the year are going to become increasingly penalized. So as we learned yesterday in advisory, make good choices because there are consequences to those choices, okay? So we got -3 cosecant of, now I got to factor out the coefficient of x, which is a -7/3, and the x term is first. So I'm going to go ahead and write -7/3. Oops, that was not right. Parentheses, and I'm going to have an x plus or minus something, something. I'll come back to that. The +5 goes to the back. All right, so here again is what I'm going to do. I'm going to focus on the sign first. It's kind of easier to focus on the sign and then the magnitude. If I factor a negative out of a negative, what's the sign going to be? Positive, okay? And some people left that as a negative. If you had that as a negative, then you already lost the first check, but you could have recovered it, and I'll talk about that. All right, so here we go. 5 pi, that's what we're starting with, and we're dividing out a 7/3. So that is 5 pi now times the reciprocal, 3/7 over 1. Nothing divides out, so we just multiply straight across, and we get 15 pi 7. And that goes right here, 15 pi 7. That was the first step, but then the whole shouting all caps thing, we have a negative b value. So in this case, because we're dealing with cosecant, which is what? Even, odd, or neither? I always forget. Odd, good. We bring the negative out front and change the -3 to +3, or we just forget about it? Bring it out front. Right, okay, cool. So here's your final answer. F of x equals +3 because it's negative up front. When this one comes out front, it changes the sign. Cosecant of +7/3 x plus, you got it? Thank you. 15 pi 7, close, +5, and that was the first check. Okay? Yeah. Uh-huh. Well, I did change the inside, right?
No, but like, why wouldn't you?
Why wouldn't I do what? I'm sorry. No. That's why we have to factor it out first. That's why we factored out this. You could think of x plus 15 pi 7 as your input, right? The parentheses kind of guard that. So this is your b value. So if we took the negative out first without factoring out of the 5 pi, now we're going to get the wrong value of c. But once it's in standard transformation form, then we can focus just on the b value. And it does not affect the inside anymore, okay? All right? It does not affect the inside. So that's why we have to factor it out first. Okay, so if you missed any of these things, you're going to lose the first check. Some people still had a negative in front. Some people had x minus 15 pi 7. Some people did not close that last parenthesis, which I did not count off unless you did not close it again on number 11. I kind of let the first occurrence just kind of go by the wayside, turned a blind eye to it. All right, now you could still recover if you have anything wrong, and I'll show you how we can do that. All right, the period. So you always want to use proper notation. Remember, the free response is about communicating your results. So practice proper notation. P is, for cosecant, what? 2 pi or pi over b? 2 pi. So you don't have to write this, but I will. 2 pi over the absolute value of b. Ideally, we like to work down. So that's 2 pi over 7/3. Now I start a new column. That's 2 pi over 1, state change flip, times 3/7. If you multiply straight across, you get 6 pi 7 because nothing divides out. That was the second check. And again, practice proper notation. If you just kind of do stuff all over the place, you're at risk of losing points. Some people still had negative 6 pi 7. Remember, period is positive. It's a length, okay? 6 pi 7. All right, now the range. This is similar to what we did on the multiple choice. It's a cosecant. So what I'm going to do first off to the side for myself is I'm going to first find the range of sine. It's my scratch work. Remember, that's d minus the amplitude for the low point and d plus the amplitude for the high point. So the d value is, if we look over here, 5, and the amplitude is 3 for sine. So it's going to be 5 minus 3 for the low and 5 plus 3 for the high. So that gives me 2 and 8. Okay, so now with that information, I'm going to come over here and say now the actual range of f, which is our function's name, is going to be not everything betwixt 2 and 8, but everything outside of it. And you can write it like this, negative infinity to 2 beefy bracket union. Now the union symbol is that. It's not, it doesn't have a kickstand on it. So some people did that. I didn't count off. And then beefy bracket 8 to infinity. So you could have done that. Or you could have said the set of all y such that y is less than or equal to 2, or y is greater than or equal to 8. So either one of those, that got the third check. Some people had -2, some people had -8. They had them flipped. So there you go. Go from left to right, least to greatest. All right, and then the fun one, find the domain, find the domain. Okay, so again, cosecant. Cosecant comes from sine. So a real quick sketch, sine starts on an axis, and remember, it's the axis points that become vertical asymptotes. So we're starting at x equals what for the first VA? 0. That's kind of important. So here we go. The domain of f, using proper notation now, is the set of all x such that x is not 0. And now we come back up here, and here's where you could recover. The correct answer is, if we're moving it left 15 pi sevenths, we must what? Add or subtract it? We need to subtract it. So minus 15 pi sevenths. If you, and I put a comma, I shouldn't do that. If you accidentally had a negative here, you lost the first check, but then in your answer, you should have shifted it right, and you should have had plus 15 pi sevenths. Some people had it wrong both times. They had a plus at the top, and they had a negative down here. I'm sorry, they had a negative at the top, and they had a negative down here. So that would be wrong. It has to match your equation. So this gives us the new VA, and then multiples of how often they occur. So if you remember for cosecant, one cycle has 2 VA, so they occur every half period. And so if we found the period to be 6 pi sevenths, we need to take half of 6 pi sevenths. So I'll do that off to the side. Half of 6 pi sevenths. Now back in little school, your teachers told you just multiply straight across on the fractions, right? Just multiply straight across. So you get 6 pi 14ths. But unfortunately, what they should have done is teach strategies, go small before you go big. 2 goes in itself once, goes into 6 3 times. Now you multiply across and you get 3 pi sevenths, which is 6 pi 14ths simplified. I did say at the very beginning to do what? Simplify. So the best answer, the correct answer in this case for the instructions was 3 pi sevenths n, where n is as integer. All right, so let's talk about it, how I graded it. First of all, when I simplify, that 0 doesn't even need to be there. So it was just negative 15 pi sevenths. That was check number 4 for this, and then this was the 5th check. If you didn't put where n is an integer, I didn't count off. You could have recovered, though, if you had the wrong period, but you put plus half of your wrong period. I checked to see if it was half of your period. You could have recovered both the 4th and the 5th check, even with the wrong information, because you're using wrong information correctly. So there's not a double penalty for that. So again, you could have recovered. Okay, any questions on that? Yes? Absolutely, yeah. All right, so the last one here, we got 4 minutes. Let's make it happen. Same thing, put it in standard transformation form. F of x equals 7, tangent of the x terms first, so I factor out the pi fourths, and I get x minus, it's going to stay negative because we're factoring out a plus pi fourths. There's a second closed parentheses, and then a minus 8. Some people forgot to bring that minus 8 down. Oh no, that's unfortunate. Now again, I don't know what I'm doing, so I'm going to come over here. I'm starting with the 2 pi, and I'm dividing out a pi fourths. So that's equivalent to state change flip again, 4 pi's, and then pi's divide out, and you're left with ocho. That's 8. And so it's minus 8, close, close, minus 8. So that was the, 6th check? And believe it or not, this was the most correct answer that most people got correct on the back. Kind of astounding. More than any other question on the back, this was the question that most people got correct, putting that in standard transformation form. All right, the period. That's going to be pi over the absolute value of b. And for us, b is pi fourths. So that's pi over pi fourths. And again, here's where you want to be careful. It's not just 1/4. You actually want to state change flip it. That's pi over 1 times the reciprocal of pi fourths, which is 4 pi's. Those divide out, and now you get 4. So that was the, 7th check. The range. This, I thought, would be the most correctly got question on the test, but it was not, okay? Part A was. Some people tried to find ranges that were not correct on this one. This one is all real numbers all day long for tangent and cotangent. They run north and south forever and ever. Or you could have said interval notation, negative infinity to infinity. And I even saw a couple of these. I like this. The set of all y values such that y is an element of the set of real numbers. And I'm like, heck yeah, that's right. You're the kind of person that puts Grey Poupon on your hot dog. Fancy. I like it. Okay? That's correct. That's good. That's perfect. I love it. All right? So either one of those was the 8th check. All right, 2 more checks to go, and it's the fun one, domain. All right. So, oh, by the way, this should have been g of x. That's what was pointed out to me, so that didn't affect the problem really. So tangent. So very quickly, here's the sketch of tangent. Da-da-da, da-da-da. It has its first VA at the first critical value. Okay. The first critical value for tangent is the half period, because we count by half periods for tangent and cotangent. So if the period was 4, half of 4 is 2. So the domain of G is the set of all x such that x cannot equal 2. So that's where it starts originally. And then we shifted it what? Right 8. So that's going to be plus 8. And then that was your 9th check. And of course that becomes 10 eventually. Plus multiples of how often they occur. They occur every what? Full cycle or half cycle? Full cycle, right? So that's plus 4n, where n is an integer. And that would be the 10th check. And that's it. Now, once again, you could have recovered. You easily could have recovered. If you started at 2 and then you shifted it correctly based upon your equation and got a different number, that was great. If you had the wrong period, but you put multiples of that full wrong period, you got the 10th check, okay? Now, some people were kind of clever. They knew it was 10 plus multiples of 4. Someone said, I'm going to kind of try to stump Mr. Corpy. I'm going to go like 3 periods, 3 cycles of 4. 3 times 4 is 12. 10 minus 12 is negative 2. I'm going to put negative 2 plus 4 in and see if he counts it wrong. And I did, and I counted it right. So that's fine. You can get to any vertical asymptote, all right, so long as it's correct. All right, so there it is. I recorded it. If you need to watch it again tonight, work it again. You got your test. You got the right answers. 7:30 is the retest. Enjoy the rest of your World Kidney Day. It only comes once a year. Take some burden off of St. Benedict.